capabilities as described by the industry today, private clouds and public clouds. Those operated on your behalf and governed by policy of a single company that could be located internally or externally, and public cloud generally externally run as a public commodity for the most part. So here we had virtualized data centers and standalone data centers talking to public cloud and virtualized data centers talking to private cloud. Well, what happened in the last year or so is that the public cloud providers realized that if they wanted to capture large enterprise business, they had to start adding features and functions that look like large enterprise. And in many cases, as I talked about before, and I'll talk about more, the thought that you would just pick up applications and move them to the cloud without re-architecting and rewriting them is kind of nonsense. So what they discovered was we need a way of allowing public clouds and private clouds and virtual data centers and standalone data centers to interoperate. So they introduced this notion of virtual private clouds, in which case now simply we have standalone data centers talking to virtualized data centers, which in turn talk about virtual private clouds, public clouds, and private clouds, with private clouds talking to virtualized data centers, ultimately public clouds, and then kind of an overlay of VPN capabilities. Still kind of simple. You kind of understand where things are going. But then what we realized was, in the absence of standards or APIs or certain capabilities and federation, we are lacking some functions. So then we stood up this notion of cloud brokers. So cloud brokers ultimately see standalone data centers talking to virtualized data centers, talking to private cloud, talking to public cloud, talking about virtual private cloud, which in turn talk to cloud brokers, which talk to public cloud and private cloud, offering you services which are ultimately supposed to deliver and fill in the gaps that don't exist today because of the lack of standard federation, workload portability, etc. Well, then they said, as APIs start to emerge, and we get a little bit better interoperability and we start to see commoditization, things start to stabilize, then what we see is this move to hybrid clouds, which is really a mixture of virtual private clouds, public clouds, standalone data centers, virtualized data centers, all talking to one another, ultimately then interacting with the cloud brokers to fill in some of the gaps. Still pretty simple, right? I mean, you may understand how this works. Well, ultimately then, way down the line here, we're going to kind of sprinkle on the magic pixie dust and end up at this thing with called the intercloud, which if you connect all the dots and all the arrows and slow down what I said, what the intercloud really means is the model of cloud will just arrive at the same model as the internet. We have open standards and APIs. Some things you keep private, some things you keep public. We have capabilities that allow us to enforce some access control, maybe better identity, better sets of services, everything living in harmonious glee. But the reality is when you look at all the arrows here, it's very difficult, without even overlaying the notion of mobility and the consumptive model I talked about in the beginning, how any of this will be easy to secure, since each one represents a separate model, even though they may be overlays or hybrids of one another. So this is kind of the problem. So let's break this down a little bit. So when you hear about cloud, you're going to hear about these three models: software, platform, and infrastructure as a service. They are targeted at three different groups. Software as a service is end users. Platform as a service is targeted to developers, let them build apps. Infrastructure as a service is targeted to sysadmins. So from a security perspective, it's interesting to see what this means and what this looks like. So I built a little set of models I've talked about before, but what's interesting here is all of the infrastructure, the compute network and storage facilities, the core connectivity and delivery, and layers of abstraction with a set of APIs in infrastructure as a service is the responsibility of the provider to not only operate, but to secure. Everything above that, here, the VMs and containers, OS and applications and data, is the responsibility of the consumer. So in infrastructure as a service, while the moving parts are hidden from you, you are still responsible for securing the operating systems and the apps and your content, just like you always have been, just kind of outsourcing the moving parts. So providers here maximize availability of their platform and pretty much nothing else. You are responsible for doing the rest and taking advantage of the platform to potentially leverage some better capabilities. So the general focus here is then, from a security perspective, less about the network, since that's abstracted, and more about the host. To give you an example of what this looks like, here's the terms of service from Amazon. You bear sole responsibility for the adequate security, protection, and backup of your content and applications. That should give you a warm and fuzzy, right? I thought I was outsourcing this stuff and I'm going to get better security. Well, it depends. There's a balance, right? There's a certain amount that you still have to deal with. When you look at platform as a service, which is really, if you in a classical stacked model, the same as infrastructure as a service, with a set of developmental and application frameworks that you can write apps to, the line just moves up a little bit more. Now, the good thing about platform as a service is you actually have the opportunity to get rid of entire classes of programmatic issues, because, for example, I could do type enforcement, class enforcement. I could get rid of stupid things like potentially buffer overflows by enforcing that at the programmatic API layer when I write code. But still, you are still responsible for the security of your apps and your data, right? So strangely enough, securing applications is still pretty important. And when you look at platform as a service, here is Google App Engines. You are responsible for the security of your passwords. This is the security section of Google App Engine. More warm and fuzzy. So if you look at software as a service, and I'm not talking about plain old web apps, POWA apps, which were yesterday kind of could be monolithically stacked, could be no virtualization whatsoever, that now have the word cloud in front of them. I'm talking about new generations built on infrastructure and platform that allow you to leverage cloud capabilities. But in this particular case, really from an operational perspective, the provider owns the security models, and you may configure policies to support what they offer you, but they're really responsible for that offering. Soup to nuts. And this actually kind of, Salesforce does a good job of spelling this out. We shall maintain appropriate administrative, physical, technical safeguards for the protection, security, confidentiality, integrity of your data. So that's a little bit more warm and fuzzy to me. And ultimately, they get to do that because there is a trade-off between functionality, extensibility, and security that with SaaS, since they govern the whole space, they can enforce things and stop you from making stupid human tricks, perhaps more so than platform or infrastructure as a service. So that's kind of the base tenets. But what this means to security here is that when you compare these three models and where the line is drawn, really the lower down the stack you go, the more responsible you are. So in software as a service, you RFP or contracted in. A lot of the stuff is contractual. Like, hey, we promise to do this. Great. If you don't, then what? You lose all my data, then what? And same thing with service levels. When you go down the stack here, you really still have to build the majority of it in, right? If you spin up an AMI on Amazon when you haven't armored the operating system and your applications suck, whether you did that internally or not, you'll be one of my taglines is you'll be pleasantly surprised by the lack of change when you move to cloud. Right? The reality is if you suck internally, you'll suck externally even more with more availability. So ultimately, you got to build it in here, right? And that's important because by merging those technical and consumerized versions of cloud, like people are like, they talk about cloud singular with a capital T, like the cloud, like there's one thing called cloud, and there's clearly not. So when we start thinking about these models and doing risk assessment, understand what this means, we really have to understand that depending on these delivery models, the availability for compensating controls, in some cases get abstracted to be good enough. They may not even be available to you. It means that the provider, in abstracting compute, network, and storage, in this simplifying process, essentially can limit entire classes of visibility and transparency. And ultimately, even with the potential for APIs and open interfaces, when it comes down to cloud, you really end up still being at the mercy of what the cloud provider tells you they do. So it all comes down to trust, which is not unlike everything today. With virtualization, you trust in the hypervisor and you trust that the vendor ultimately has done a good job. But there's this really notion. To me, there's a notion of corrosive trust, right? It's security by obscurity at levels I don't think we've seen in quite a while. What I mean by that is if you look at, for example, the virtualization underpinnings, most of the cloud providers today from an operational perspective is based on faith or SAS 70. I'm not sure there's a difference. So we have, we've been asked that essentially trust providers, trust protocols, trust hardware, trust software, trust operations and people. No difference in cloud than outsourcing to a provider, but now we're talking about massive scale and this notion ultimately of multi-tenancy. So when people think about this, they think about really the issue of control. Trust does not equal control. We talked about trust. Ultimately, cloud is all about gracefully losing control. I'm basically saying, here, have my stuff. Please do good things with it. Control is often an emotional issue to security people. We can't necessarily justify why we think it's a bad idea because we don't have visibility in some cases, or we don't have the ability to say there's an exploit. That's why not, right? We in some cases have to rely on strange voodoo dances and chicken dolls. But the point is, we say I'm not giving up control of my content and data. And one of the interesting things that goes back to that 8-ball presentation is people are really worried about, security people specifically, about putting their content and data in other people's hands. I maintain that if you hold up what's in your pocket now, most of that application and content is already quite literally in other people's hands. And the issue here is that when we talk about control, we're kind of unprepared for what that does to us operationally. So in many cases, we can get over some of this by saying, look, if I only had some of this transparency and visibility back, so I understand what you're doing with my apps and content, then I'm able to actually focus on the things that matter most. You can deal with the operations. I just want to be able to understand what's happening. The